This video will explain how redistributing space can create better homes and better neighborhoods. Let's take a look at 25 years ago in Mesquite, Texas. This was the original 244 lots to regulatory minimums that was proposed, so we took a look at it and used this method what we called coving. It's a geometric model to redistribute the space of the development. It's got two less lots. It has the exact same regulatory minimums. It met all of the code, but it has 42% less street and utility main length and 40% larger lots. It's one of the first neighborhoods that included meandering walks to add elegance to the streetscape. This is the typical subdivision geometry that you'll find anywhere on the planet. So where is the waste in this design? The streets we see in yellow, they're half fronted. What does that mean? Well, one side of the street has homes fronting it. The other side of the streets have homes that are either siding it or rearing it. That's 50% utilized. Now, when we take a look at the street that's 100% utilized, that means there's a home fronting both sides of the street, which means 0% waste. We see there's quite a bit of waste. Now, we do have one cul-de-sac on the right that is questionable if it's efficient, but there's two. The way they're laid out is extremely inefficient for space. So approximately half of the streets that you see are wasteful. There's another form of waste, and that is to get home, most people have to negotiate multiple hard turns. Now, a car isn't going to maintain that 25, 30 mile an hour speed through the neighborhood through a hard turn. So from a perspective of time and energy, most of these developments that look efficient actually are extremely wasteful. So are you beginning to understand why waste is so typical in the world's developments? Today's regulations and planning theory are based on methods of the past. Software that's available automates only those past methods. You can eliminate waste and begin a new era of growth by rethinking and retooling. So we're going to use Winfield Coves as an example. This is the original plan that was gridded. It's a subdivision to regulatory minimums, with the streets being the pedestrian system. They parallel each other at minimum lot depths, and the grid typically ignores the organic, natural flow of topography. If you desire walkability, the only way to really create walkable neighborhoods is to design the main trails first. On the site, we begin with a circle, a 10-foot wide path in a 30-foot wide landscaped area, 2 miles in circumference. The city wanted 3 schools, and they connect into the main trail system. Commercial uses are also conveniently located along the main highway, but it also can be accessed fairly conveniently through the main trail system. You can see there's an extensive network of interconnecting walkways that go to and from the main trail system. So essentially what we want to do in any development, especially a large development, is create a pedestrian highway system as the first element of the design. Do you desire drivability? Well, we have to create a street system that maintains flow. So there is a requirement for 2 major collectors to go through the neighborhood. We have one north-south collector, and from that we also have 2 minor collectors. The curves discourage speeding, but they maintain flow. Linked into this collector system are individual pods of development. Each pod, once you enter it, also maintains flow so people can get home easily and quickly with less energy. And you might notice that street patterns do not parallel at the least possible lot depth. We're not trying to parallel to the regulatory minimums to squeeze the least possible front and rear yard spaces. Let me talk briefly on what we call diffusers. When we have the main trail crossing a street of traffic, we put a pedestrian diffuser in it. That's an island that allows the traffic to maintain flow, but pedestrians to cross it one way and then stop in a wide island and then cross it a one way, which is much safer. There's also vehicular diffusers. Now they replace a traffic circle. A traffic circle, everybody gets slowed down, but we don't want to slow down on main traffic roads. So think of them almost as like an elongated roundabout. They maintain flow on the primary street, but they somewhat act to diffuse traffic. This is an example diffuser of Tres Lagos in McAllen, Texas. It's an entrance point for this future commercial center, and it's also an entrance point for a potted development on the other side. But it diffuses traffic. It's very attractive. It signals the entrance of a pod, and then there's multiple ways you could turn around and diffuse traffic. Here's another diffuser. This goes into Estancia. It's custom homes to the north. So every potted development signals the entry on our main Tres Lagos Boulevard is served by a diffuser. This is a diffuser being built in Winfield Coves. You could see this is where the main trail is going to cross. Pedestrians can stop, look at traffic one way, have plenty of room to then go to the other lane, stop, and see traffic the other way. The entire street system was designed to adhere or honor the natural flow of the topography. I want to talk a little bit about this idea of redistributing space and how it affects the homes themselves. When you think about new urbanism, and then you look at how efficient or inefficient the street is, these are streets with no frontage whatsoever, the yellow. It's 100% waste. So you're also building a street in the front of the homes that are pretty much 100% utilized, but then you also have to build an alley in the back. What you've got is a site you've consumed with right-of-way and pavement, leaving little space for the homes. So you have very little front yard, you have almost no rear yard space. When you take a look at the home itself, it's fairly attractive. It's a front porch living, rear garage. They are narrow and they are generally deep. There's a minuscule percentage of that perimeter of the home that actually is viewable. The side view is non-existent. It's only the front view. They parallel each other so that width is your presence. So you're looking onto parked cars in the front and onto parked cars in the rear. How do you create walkability? You have to build more street. But we're going to take a look at that home and we're going to rethink that home into what we call a bay home environment. And we can achieve more valuable, better livability, far more space, and better function with far less pavement. This is a bay home neighborhood that is in Rochester, Minnesota. You'll notice a few differences. There's not necessarily a street in the front. A larger percentage of the home has a quality panoramic view because we're staggering the homes. An increased facade exposure increases the curb appeal. The front view on some are parked cars if they do front to street, but not all of them front to street. That's a 2 or 3% of your entire day that you're in the back of the home, parking your car, going in and out of the development. We're more worried about that 97 to 98% of your day where you're actually living in the home on the opposite side of where the garage is. So we're redistributing the space to squeeze the space garage to garage and then increasing the space where you actually live. So for walkability, we build walks, not streets. With a zero lot line style, we have private space to put a patio along the side of the home that can be screened, but we're also using it to park along the side. We're not parking in back of the garage, we're parking along the side, and that way we could squeeze that distance garage to garage and open up the distance where people live and not where cars are parked. So this is a bay home in that same neighborhood. We're looking at a full front porch, at balconies. This one's a walkout, and in this case it overlooks the ponds and not parked cars along the street, not directly into another home directly across the street. The feeling of openness is incredible, and yet the densities that we can achieve are very surprising. This is another example of a bay home. This is Water Lily in Edinburgh, Texas, soon to be under construction. Tremendous amount of parking, convenient guest parking that leads to the front porches and waterways. pretty much ditto everything I just showed you. And this is a rendering of how Water Lily will look when built. Again, we're redistributing space so we could reduce the space that we're dedicated to park our car and increase the space dedicated to park our people. And that allows us to have a tremendous amount of space, fairly large homes, and still achieve over 6 units per acre. This is a neighborhood we're proposing, again, in our development in Rochester. We have staggered the homes, but this is now lower income housing. These homes are anywhere from 1,000 to 1,200 square foot. They're an alternate to renting an apartment. And this is what it will look like when it's built. You're looking at almost 12 units per acre, single family detached. Again, panoramic views, full front porches, generous setbacks, generous open space. Every front porch is connected with a walk or trail. Now, while the bay homes are an alternative for attached housing or maintenance-free single-family living, we'll talk about what we know as your standard suburban home today, your freestanding home that typically is served by a street and a garage in the front. By taking advantage of these new lot configurations, we can increase the home value and function through what we call architectural shaping. So if we hold a constant minimum angle between the lots, we can create floor plans that expand in the front or the rear of the home. So in this example, we're using a 70-foot deep by 35-foot wide building pad. And we start with a hypothetical home to show you how this would work. Now, we're going to use the same 1,875 square foot within that perimeter, and we're going to widen it at the front of the home. So we have a less deep home to maintain the square footage because we're widening along that angle, so we have a larger rear yard. What was 35 foot wide along the rear is now 40 foot wide. We decided to set the garage back 4 feet to de-emphasize the garage floor impact, and typically when we design a new neighborhood, we also ask for a front porch to extend into the front setback line. But either way, we're going to have less garage facade and more curb presence on the inside arc lots because we can widen the home at the front. So when we look at the square footages of each one of the spaces before and after, they pretty much across the board increase. So we have increased functional space within the home because we don't have to serve it by narrow hallways on a narrow, deep home. We have reduced and simplified the wall construction so that it might be less cost to develop this new home, but we increase the perceived living space, the space you would feel immediately as you enter the door, by 36%, and yet we're maintaining the exact same square footage. That is when the angle of the home pie shapes to widen at the street. But what about the opposite, widening at the rear? So we could still work up that angle. We can't do anything about the garage not being so prominent. But we're going to hold the same 1,875 square foot, rearrange the room that gets 5 foot wider, working that angle so there's more curb presence. We're now 40 foot along the rear instead of 35. And in this case, we have to use methods to soften that garage impact. So we did recommend adding some feature that's dominant, and the porch is a good feature to add. So we've increased the views into the rear yard because it's wider. We can put more room functions, more windows to that larger rear yard, and it also typically gets larger in the front because these lots are typically the ones that are set back from the street further than the regulatory minimums. All living space, again, is perceived as bigger because we are eliminating most of, if not all, of the hallway space. So these are architecturally shaped homes on lots that are holding a consistent angle. They're considerably wider at the front than you would see on a typical 35 by 70 foot pad that's shown towards the left. There's a rectangular home there. It'll have a wider at the rear, and typically those rear yards are larger. And this is another example of how a coved pattern differs. The minimum front yard is the existing minimums. So if it's a 20 foot, that's our minimum front yard. Exceeding the minimums gains efficiency. So it's in a completely unintuitive way to design. In other words, we're gaining tremendous efficiency by not reducing any regulatory minimums, but actually exceeding them. Its density is based on setback length, not street length, in this new model of development. Along minor collectors, deeper setbacks allow a driveway turnaround so homes can front minor collectors. So that street is being built with homes fronting them instead of a cold wall with double frontage homes and the back of the homes along collector streets. Now keep in mind the building setback and the streets can form two completely different patterns with this model. So here we have a major collector street and the homes fan out so that we could front the homes on a major collector street. The neighborhood becomes far more attractive, and you don't have a street in the back and a street in the front of the homes. This is just one example on how this method can free us up to do some incredible things with design. When you're looking at the angle relationship of these homes, and then you can imagine looking out the window, the line of sight is considerably larger than the line of sight from within the home to the outside on a gridded development. Let's look at a cul-de-sac. We typically would oversize our cul-de-sacs, go one way with the street. The street pavement actually overall goes down and the density goes up as we increase the depth from the cul-de-sac to the home. So we gain more premium lots. The increased setbacks allows for elegant meandering walks. The cul-de-sacs no longer are closed pedestrian loops. You don't have a system where the cul-de-sac destroys pedestrian connectivity. If anything, it adds to pedestrian connectivity. And if a cul-de-sac is longer than the regulatory minimums, that trail or walk can be used for emergency vehicle access. And there's plenty of room for street trees to grow. So what's so different about the geometry of this design versus a conventional subdivision? We're holding all of the existing regulatory minimums. We're not asking for less. But what we're doing is we're creating larger dimensions than the minimums. When we look at it, lots are dimensioned to the front setback when that setback depth exceeds the minimum, so we know where to build that home along that front setback. That front setback is at the regulatory minimums. Tangents are eliminated on reverse curves. Tangents add a lot of inefficiency, and with today's technologies and everything being done in CAD versus hand calculated in the centuries before, tangents are not necessary on residential speeds. Meandering walks are defined by public easements. So when we look at the plat itself, the only thing that we're adding that's different than a conventional plat is we're dimensioning where that front setback line is. That is the only physical difference on the plat besides the easements that we would write for the meandering walks when they meander outside of the right-of-way. And the lot lines are not the first thing in the design process. Lot lines are developed as the last thing in the design process, because when you lay out your streets and then you put your lots in and everything else is an afterthought, it's not possible to create a better neighborhood beyond normal subdivision platting. So the processes are different. We're starting with the architecture. We're looking at different things. What we're talking about is redistributing space so that we could free up land, get rid of the waste, and then we could do these wonderful things today that we could never do in the past because of the geometric complexity that would have been impossible to compute. So today we could create neighborhoods that are beyond the imagination of what we could do even 20 years ago. Here's an example at Trisona in Vieira, Florida. These homes were 35-foot wide by 70-foot deep products that are now much wider. Look at these homes here. Would you guess that that is the density of a 35-foot wide home that would have normally been on a 45-foot wide rectangular lot? Again, we did not decrease the density. In fact, we increased it a little bit from the original gridded plan. We picked up the space by reducing the street length paired to the original plan by 38%. This gained 19.6 acres of open space we're able to redistribute. That redistributed space goes into the front, rear, and if you think about it, because of the angle relationships, the side yards. This space is what you feel everywhere within the development. It's enhanced by the meandering walks. Look how elegant they are. That space, it's like living in a park. There's two main circular trails in here. You could see the pedestrian diffusers, and then you could see the sculpting of the neighborhood, and the space constantly changes. There's multiple parks along that main trail, and then we have a straight trail that cuts through the neighborhood so you can conveniently walk directly through the neighborhood.